Good day, everybody. Once again, we are back together. All right, and then today we are going to look at two-dimensional trigonometry. So if you haven't subscribed, please do the right thing. And of course, if you do need some assistance, you can get in touch with us. Let's get right into it, ladies and gents. Right, now you would have remembered in grade 10 actually, right, that you would have actually encountered a 90-degree triangle. Right, let's draw a proper one. Okay, so you would have had a 90-degree triangle, and in your 90-degree triangle, you remember certain things about it, right? So suppose that we've got an angle theta, which is given over there, right? So we've got several things that we know. First of all, we know that we've got a side which we always refer to as the opposite side, right? And remember, the opposite side is the side that is directly in front of the angle, right? And we also have the adjacent side. This is the side that's next to the angle. Adjacent just simply means next to the angle, right? So you've got the adjacent side as well as what we call the hypotenuse, right? So this is the hypotenuse. So I always get the spelling wrong, actually, the hypotenuse, right? So this is the hypotenuse side. The hypotenuse is usually the longest side in your 90-degree triangle, right? So these are the three sides that you'd have in a right-angled triangle, right? So remember, you've got your trig ratios that we use, and our trig ratios are as follows. If I wanted to get the sine of theta, these are just the ratios, right, that tell us about the different sides of the triangle. So if I wanted to get the sine of theta, some of you call it sin theta, right, you know that you will use the opposite side divided by the hypotenuse, right? But if you wanted the cosine of theta, which is cos theta in short, right, we will use the adjacent side, okay, divided by the hypotenuse, okay? And finally, we've got the tangent of theta, otherwise called tan theta in short, right? That would be the opposite side over the adjacent, okay? Right, now these are the three trig ratios that we use over and above, in this case, what we would normally use just for the sides, which is our Pythagorean theorem. We'll talk about that a little bit later. Right, now we've got this, and we said you can use the, the mnemonic way that you can remember this easily, which is Soka Toa, okay? Now we know what to do with the right-angled triangle. We know how to go about that. And we know that whenever we want to find out one of the sides given the other two sides, we always use, in this case, the square of the hypotenuse, right? R squared, which is equals to x squared plus y squared. We say the square of the hypotenuse equals to the sum of the squares of the other two sides. Right, now that we've just laid the foundation and just reminded you of just the important stuff on the right-angled triangle. Now, what happens when we do not have a right-angled triangle? What happens when we've got an angle other than a right-angled triangle, right? So we now have just other tools that we're going to use, and I'm going to just start with the sine rule. So suppose that we've got triangle ABC, right? And triangle ABC, as you can see there, is not a right angled triangle. So meaning that we cannot use our trig ratios, right? So what are we going to use in this case? Well, we say that we're going to use our cosine rule, our sine rule, as well as our area rule. Now, the sine rule, let's say the sine of the angle, so sine of angle A divided by the side opposite A, we call this small a, which is side BC, right? So we've got the side opposite B, which is going to be small side B, which is AC, and we've got the side opposite angle C, which is small side C, right? Which is opposite that angle there. So we say the sine of A divided by the side opposite that angle, which is C, which is A, right? Small side A is equal to the sine of angle B over the side opposite that angle B, and in this case divided by the sine of angle C divided by small side C. Now what I'm going to do in the future videos is that I am just simply going to be showing you how to use or rather how to derive these rules, right? This is what we call the sine rule. Some call it the sin rule. Okay, it doesn't matter how you decide to pronounce it, right? We all arrive at the same thing. Right, now, how do we use our sine rule? When do we use our sine rule? So first of all, if you ever given two sides, right? If you've got two sides and you are given one angle, right? So we are going to use the sine rule. And of course, we can use it when we do not have a 90-degree triangle. Now, two sides and one angle, but it should be any other angle other than the angle that is between those two sides. And I'm going to tell you about that later. So any two sides and any other angle we should use the sine rule, right? And then if we've got two angles, right? If we've got two angles and one side, okay? So one side, we know that we are also going to use our sine rule in that case, right? So now we're going to take just a couple of examples in just a few, but I'm going to give you the other rules now, right? So then we also have the cosine rule, right? Now the cosine rule, guys, I want you to please remember, we will only use the cosine rule when we've got two sides. So two sides and an included angle, right? Included angle. Right, now note, what do I mean two sides and an included angle? Let's go back to triangle ABC again, right? Now, if I should ever tell you, let's say there's our triangle. Let's say this side is 50 meters, okay, and we say this side is 60 meters, and I give you the angle in between those two sides, right? So let's just say for argument's sake, that is 70 degrees, right? So two sides and the angle in between those two sides. So only in that case can we use the cosine rule. Now, what does the cosine rule actually state? Now, you remember, what did we say? Well, let's just take our triangle ABC. We said this is called small side A, this is called small side B, and that would be small side C. So if I have A squared, that will be equal to B squared plus C squared minus 2 times B times C. The cosine, notice it will be the included angle, and in this case that will be the cosine of A, so that will be the angle. So meaning, if I were to look for angle B, right, or rather if I'm looking for side B, again, that's B squared is equals to A squared plus C squared minus 2 times AC, the cosine of angle B, which would be the included angle. So if I'm given side C and side A, the included angle will be B. And of course, if you've got A and B, right, the included angle will be C. But just like we said in the beginning, if we are given B and C, the included angle will be angle A. Right, we're going to take some examples of these. But of course, you do note that if we wanted to get c squared, we'd say this is a squared plus b squared minus 2ab, the cosine of angle C. Now remember, two sides and an included angle, or whenever we are given the three sides, right, and we are looking for the included angle, in that case between two sides, then we are going to use the cosine rule, right? So that would be what the cosine rule looks like. Now, I want us to quickly look at the area rule, which is the other rule that we use. So this is the area rule. And given that we are looking at two-dimensional diagrams, right, we look at the area rule. Now, the area rule, again, given that we've got triangle ABC, right, which is not a 90-degree triangle, so you do not have the perpendicular height of that triangle. So what do you do in that case? So if you're given triangle ABC, right, so we simply say that the area, right, of triangle ABC, now several things. Again, you are going to use two sides and an included angle. So let's say this is A, and that would be B, and this would be C, right? So the area would be a half of two sides, right, and the sine of the angle in between those sides. So again, two sides and an included angle. So if I say the half of, let's start with B times C, right? So B and C, which one is the included angle? That would be angle A. So this would be the sine of angle A. But of course, you can use the other two sides. So that would be half of A multiplied by B, right? That would be, so if I'm using A and B, the angle in between would be angle C. And of course, if I wanted to use the other sides, that would be A multiplied by C. That would definitely be the sine of B, angle B, right? Now, as I said, I will prove these, these rules, how to go about proving them, right? So we will do that in the near future. So what I want us to do, ladies and gents, is to go about, just using these rules and see how to apply them to solve trigonometric problems. And let's take our very first example. They say in the diagram we've got angle P, which is 67. We've got PQ, which is 3 centimeters. Note the units. And PR, which is 9.2 centimeters. Determine the length of QR. Right, so now we are going to look at what we actually have. Now note, when I look at this, I can see that I've got two sides, right? So if I look at this on my triangle, I've got two sides, right? Which is these two sides. And do you see that I've got an angle in between, right? So which is angle P. So in this case, I've got two sides and an included angle, ladies and gents. So I'm given side PQ, I'm given side PR, and I'm given the angle in between those. And I'm looking for the side opposite that angle. So definitely this calls for the sine, the cos rule, the cosine rule, right? So let's do this. So this would be QR. Now remember, we always say the side squared equal to the other two sides. So I'm looking for QR. This will be PQ squared plus PR squared minus the very two sides, that's 2 times PQ times PR, right? So the same sides as we had, right? The cosine of the included angle, our included angle here is angle P. So I'm going to indicate that as angle P, or you can say angle QPR, right? So now let's substitute what we have. We've got, right, PQ That was 3, right? I'm not going to substitute the units. Plus 9.2 minus 2 times, that's 3 times 9.2, the cosine of 67. All right, so we need to find what the value of QR is. But remember, we've got QR squared, so which means that we have to use the square root at the end, right? So we're going to have 3 squared plus 9.2 squared minus 2 times 3 times 9.2, the cosine of 67. Please always make it a point that your calculator is in degrees so that you don't end up with the wrong answer. Now, ladies and gents, it's really not worth it for you to write down the answer. Let's rather find the square root of this so that we can minimize, having to round off before we get to our answer. So square root of our answer gives me, well, it depends. If the examiner said to 1 decimal place, would say 8.5. But if it's to 2 decimal places, I'm just going to say 8.49. So that means the value of QR, right, would be equal to 8.49. And remember, our units are given in centimeters, right? So that is how I would get the value of QR. Now, just suppose, ladies and gents, suppose that they had said to us, calculate angle Q. All right, so let's just say, let's look for angle Q. So if we wanted to find out what is the value of this angle here, right? So in this case, what we're simply going to do, now we've just found out this value is 8.49 centimeters, right? That's what we got from our calculator, right? 8.49 centimeters. In fact, because that's given to 1 decimal place, I'm just simply going to convert to 1 decimal as well. So let's say 8.5 centimeters, if you don't mind. Right, so I'm going to change that to 8.5 centimeters. So we're looking for angle Q. So now notice that I can now use the sine rule, right? Because I've got at least 2 sides and another angle. So I'm going to say, well, the sine of angle Q, right? Remember, you use the side that is opposite that angle. So if I'm looking for this angle, right, the side opposite that angle is side PR, right? And I'm going to use an angle that is already known to me and the side opposite that angle. Okay, right, please keep that in mind. So sine of Q divided by side PR is equal to the sine, our known angle is angle P, divided by the side opposite to P, angle P is QR. Right, now we can substitute, or if you want to, we can actually work out find the subject of the formula. So in this case, I'm going to say, well, we're looking for the sine of Q. Okay, sine of Q divided by, remember our PR is given as 9.2, which is equal to sine of 67, right, divided by QR, which we just found as 8.5. So if I were to cross multiply there, so that means I'll have 8.5 sine of Q is equal to 9.2 sine of 67, and we can divide both sides by 8.5. All right, so that cancels with that. So sine of Q, okay, I keep writing theta there, is equal to that entire thing. But remember, when I'm looking for an angle, right, I'm just simply going to say, well, that means angle Q would be the arc sine. Remember that we find the angle by taking the arc sine, right, of this entire thing. So I'm avoiding having to round off. So 9.2 sine 67 divided by 8.5. So I'm going to try and work that out. Okay, so what does that give us? So I'm going to say shift the sine of, right? So that's the arc sine. Okay, I open my bracket. That's 9.2 sine of 67 divided by 8.5. Okay, I'm going to close that entire bracket there. And I get angle Q to be equal to 85. Well, if you want to, let's say 85.1 degrees, right? So that would be the size of my angle, right? And of course, if you wanted to find the other angle, so we just found out that this angle over here is actually equal to 85.1 degrees, right? And of course, if you wanted to find the other angle, what we can use is the sum of angles on a triangle, or in a triangle rather. Right, so that is how the cookie crumbles, ladies and gents. Let's take another question. All right, now let's take another example. So this comes from a past exam question paper. They say in triangle PQR, we've got QR, which is 3 units. PR is equal to, actually QR is 3 units. PR is X units and PQ is 2X units. And angle PQR is theta, equal to theta, right? And they wanted us to show that the cosine of angle theta will be equal to that expression. Now, I want you to note firstly, they already gave us a cosine there, right? So, of course, we're going to use the cos rule. Right, now remember, we've got angle theta over there, which is given to us, right? Okay, just want to choose a different color. So we've got angle theta that's given over there, right? So if we're going to use the cosine rule, remember that we are going to use the side opposite that, right? So that means PR squared will be the two sides and the included angle. Remember, that's what we do for the cosine rule, two sides and the included angle. So I am going to say, right, PR squared. All right, let me just change the color there. Okay, so PR squared is equal to the other two sides, PQ squared plus RQ squared, or QR squared. So that's PQ squared plus QR squared minus 2 times. Remember, it is the same sides that you've got there. That's PQ times QR, and the cosine of the included angle, which is the cosine of angle Q. All right, so now we've got PR squared, but we already know what PR squared is. It is equal to X, right? So we've got it there given as X. All right, so I'm going to substitute that over there. So I'm going to say X squared is equal to PQ squared is given as 2X. So that's 2X. Remember, we square it. Plus QR squared. Our QR is 3. So that would be 3 squared minus 2 times 2X times 3. Right? The cos of, now remember, angle Q is equal to theta in this case. Right, so now let's try and do our mathematical gymnastics. So we've got X squared is equal to, this is 4X squared plus 9 minus, now 2 times 2x, that would be 4x times 3, right? 4 times 3, that would give us 12. Okay, so that would be minus 12x, the cos of theta. All right, now let's try and work it out, right? And try and simplify it as much as possible. If we bring the 4x squared to the other side, so we've got 4x squared, negative 4x squared rather, plus x squared minus 9 is equal to negative 12x, the cosine of theta. Right, so of course minus 4x plus x squared gives us negative 3x squared minus 9. This is equal to negative 12x, the cos of theta. In this case, what we can do is take out a common factor there, right, which is negative 3. So that's negative 3. We're left with x squared plus 3. It's equal to negative 12x, the cos of theta. Right, now we can divide both sides by negative 3, ladies and gents. Okay, so that cancels with that. Right, so negative divided by negative gives us a positive. And now 12 divided by 3 gives us 4. So this will be 4x, the cosine of theta. Okay, this will be x squared plus 3. Right, now please remember, what are we trying to do? Just get an expression of cos theta. So I'm going to divide both sides by 4x, right? So those two cancel. So as a result, the cosine of theta will be equal to x squared plus 3 divided by 4x. And that's exactly what they asked us to prove over there. Right, now on the next one, they say if x is equal to 2.4, calculate theta, right? So x is 2.4 units, right? So that was the next question, right? 7.2, but we're starting with 7.2.1. So if x is, right, so said if x is 2.4, which means we're going to substitute 2.4 everywhere we see x. So that would be 2.4 squared plus 3 divided by 4 times 2.4. All right, now ladies and gents, of course, let's find that expression. So that's 2.4 squared plus 3, right? And all of that divided by 4 times 2.4. Okay, of course, we get 0.9125. Okay, you don't need to write this down. All you need to do is just use the inverse rule in this case. So cos of theta is equal to that. So theta would be the arc cos of 0.9125. Okay, and what do we get? Right, so I'm going to say shift the cosine of our answer. Okay, and I get 21.15. Right, and that's how I will get that angle there. So that's how we get the angle theta, right? So now that we know our angle is 21, okay, in fact, let's also keep that to 1 decimal. So let's say this will be 21.2. Okay, let's change that color. So that's 21.2. So now what I'm going to do is go over to the next question. So they want us to calculate the area of triangle PQR. Now remember what we said about the area. right? Two sides and an included angle. So in this case, the only angle that we've got is angle theta, right? We just found out that that angle there will actually be 21.2. So the two sides are side PQ as well as side QR, right? So let's use our area rule. So area of triangle, right? So area of triangle PQR. Okay, this would be half of the other two sides, so that would be PQ and QR. PQ times QR, the sine of the angle in between them, which is angle Q, right? So let's find out what that is. So we said PQ is 2x, but remember x is given as 2.4. So 2 times 2.4, remember it's 2x and x is 2.4, multiplied by QR. QR we are given, which is 3 units. Sine of the included angle, which is 21.2. All right, now I'm going to say, so that's 1/2. That's multiplied by 2 times 2.4 times 3, the sine of 21.2. Okay, and I get the area to be 2.6. Now, note, ladies and gents, you've got units there that are given as units, right? So whenever you get the area, you must give it in terms of square units. So that's units squared. So if our units were centimeters, then we would say centimeters squared. And if we've got the last one there, actually 7.3, they say calculate the value of x for which the triangle exists, right? Now, what do we mean when we say for which the triangle exists? So for the triangle to exist, first of all, we know that x has to be a positive value. I mean, you're talking about the perimeter of a triangle or the side of a triangle. It cannot be a negative number, right? So x must be greater than 0. Let's start there, right? Firstly, and secondly, what we note there is that theta, so if you think about the just the graph of the cosine of theta, this is what it looks like, right? So we want theta to be an angle. Now, in this case, if you look at the cosine of theta, the graph of the cosine of theta, right, between 0 and 90, right, that's where we get a positive value. Of course, I'm not referring to the other sides there, right? So this is where we're going to get a positive value. So theta must be an angle between, right, 0 and 90. And if that is the case, which means that the amplitude, okay, must be between 1 and 0, right? So remember, the cosine of 90 is 0. The cosine of 0 is 1, right? So therefore, it means that, now remember, this entire expression represents the cosine of theta, right? So meaning cos theta must be between 0 and 1. All right, so now for the graph to exist, we're simply saying the cos of theta must be less than 1, but it must be greater than 0. But we know what cos theta represents. That's x squared plus 3 over 4x, right? Greater than 0 and less than 1. All right, let's start with the first one. Okay, so if we look at that, if we try to solve for it, so you'll have x squared plus 3x over 4x, right, being greater than 0, or you've got x squared plus 3 over 4x, right, being less than 1. Okay, so if you look at this, if we multiply both sides by 4x by the denominator, we end up with x squared plus 3 greater than 0. When will that happen? All the time. Now, please remember, this is a positive number all the time for any value of x, and 3 is also a positive number. So this holds for all values of x, right? So we don't have an issue there. So we'll have to solve for this. So now if we cross multiply, or if we multiply by 4x, what I do on the left, I do on the right. Okay, so we've got x squared plus 3 less than 4x. So let's put it in standard quadratic form. That's minus 4x plus 3 is less than 0. Right, now I want you to please note, right, when we go back to inequalities, we're going to have to find our critical values there. Okay, so we've got x and x, we've got 3 and 1, right? So we've got negative and negative. So if you note there, we've got 1 and 3 as our critical values. You always place them in ascending order, right? So we've got 1, we've got 3, and we know it is positive here, it is negative, and it is positive over there. Now, where is our graph less than 0? It is less than 0. Okay, where is it negative? It's less than 0 between 1 and 3. So what is our final answer? So x must be any value that is less than 3 or greater than 1 and less than 3. Otherwise, you can also say x is an element of, actually excluded 1 till 3. Right, and this is how you're going to get to your answer. All right, so essentially, ladies and gents, these are the values of x for which the graph will exist. All right, so I'll leave it there. Right, so please just have a look at our offerings. You can go onto our website, which is www.mlungisiNkosi.co.za, right? And all the description of of what you need will be on the description of this video. Rather, all the information you need will be on the description of the video. And I'll come back to prove to you the sine rule, the cosine rule, and the area rule, right? Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.